So we can also discuss different types of experimental designs. So this is not a comprehensive list. There are other types of experiments, but these are three that we'll talk about in this class. So the first is the most basic, a completely randomized experiment. In this case, we have everyone that has agreed to be on our experiment, which we'll call our experimental units. And then we just take and randomly assign them to our three different treatment groups. So the example I've been using has been the idea of homework, right? So I personally have listened to a lot of people on Twitter who have said homework is just not equitable. The people who need to do homework or don't know how to do homework, so they need help. And the people who don't need homework, it's just a waste of their time. So I opt for all of these things that sort of let you know if you need to practice more or watch more videos or what it might be, and then I give you those resources. But I'm putting it on you because we're adults and it's a time when we need to figure out, do we understand this or not, and make that decision. So I'm a big fan of no homework because I just know that other people have jobs and families and things to deal with, and adding extra crap to their workload is unreasonable. So let's say treatment 2 is textbook homework. And treatment 3 is online homework. I know that we have faculty who kind of go back and forth on this. A lot of people who like online homework, like that immediately tells you if you get things right or wrong, sort of like these little knowledge checks or little check-ins that I have throughout these videos. But one of the things that I've noticed about the difference between textbook homework and online homework is with the textbook homework, I feel like, sorry, my cat was picking a couch. She had to be killed. I feel like with the online homework, students are much less likely to collaborate. So the homework that's at the end of each of these sections, I used to assign, and it was great because I'd have students in a giant study group outside of my office working through these problem sets because they were challenging, and they felt like they had to use each other. One, because I chose those questions, so the answers weren't just out there. They weren't just publisher questions like you'll find on those websites. But also, it's just easier to collaborate when you have paper and pencil and you can get things done sort of in the moment, whereas the online homework really required that you sat down on a computer and worked on that. So anyways, let's pretend I was giving all three of these. So if everybody in this class was my group that I was going to run this experiment on, I would just randomly assign you to these three groups. There are plenty of things available online that would let you do that. I could literally just flip a coin, and everyone that was heads I put in treatment 1 until I had a third of the class in treatment 1. Flip a coin again. Everybody who got heads would go into treatment 2. There's a lot of ways that we could do this. We put all your names in a hat and just pick out a third of them, right? There are low-tech ways that we could easily do this random assignment. Hopefully this seems a lot like an SRS to you, right? There's nothing fancy going on. The big difference is that in an SRS, we are figuring out from a population who we're going to sample. So we're doing random sampling. Here, everybody in this group that we're doing our random assignment from, we're going to get data from. It's just a matter of which treatment group they're going into. So it's a big difference there, but the mechanics feel very similar. So just like with an SRS, the completely randomized study can have the same problems, right? It could happen that all of my lowest performing students, maybe everyone who got a C or lower, or most of the students who got a C or lower, end up here in treatment 1, no homework. And then when I finish up my analysis, I show that no homework has a significant decrease in student success in my class. But in reality, these were the students who are weaker on the first test to begin with. So how do I deal with that? Well, I'm going to do experimental design's answer to the stratified sample. I'm going to do a block design. So in this case, if these were all of my students, I might take the A or B students and then randomly assign them to my three groups. No homework, text homework, online homework, right? So now I know that I've got a third of all of my strongest students in each of these groups. And then I could take the C or lower students and divide them into those three groups as well. So now I know I have an equal mix of both my strong and weaker students in the same type of homework situation. So that's a block design. Like I said, it's very similar to our stratified, but again, different in terms of the mechanics because we're doing random assignment as opposed to random sampling. The last of our study design is a match pairs. This is very similar to our block design. Usually we're doing this with only 2 treatments. So in this case, let's just say we're doing no homework versus homework. We don't have the different types of homework now. Those are our 2 options for our treatments, right? Our 2 treatments that we're looking at. Basically our control and our treatment. And so what a match pair would do is that I would choose one student randomly out of the class. And I would look and I'd go, okay, this student, let's say I happen to know they got, I lost my green pen. I don't understand what's happening to my pens. Are they, no? Sorry, I'm really sad. Let's say the student happened to have gotten an A on the first exam. So what I would do is I'd find, so this is student 1, another student who also got an A on the exam. And then I would think a little bit harder, well, what are other factors that I think might influence whether or not homework is a helpful tool, right? I think if you're a weaker student, homework can be really helpful. But I honestly believe that there's some tipping point where it's just makes you feel worse, and so I think it's not necessarily a straight linear thing. But anyways, an A. What other things? Well, I happen to know that males and females learn differently, right? So maybe I think that matters. So I check out student 1 as a female, so I make sure that student 2 is also female. And then one of my students said today tutoring in one of the other classes. So I'm going to say that they have used tutoring. Because if a student has used tutoring, I know that they're willing to go out and get support, right? They know how to advocate for themselves. They know about the resources on campus, and that student's going to be more successful. That might be the student that doesn't need homework, because they're going to go out, if they don't understand something, they're going to figure it out and they're going to get help. So right now, I'm feeling like this student doesn't need homework, but I want to make sure that I have a student that's very similar to them. Also an A student, also female, also knows about the resources and uses the resources on campus. So once I've matched this person, what I'm going to do is I'm going to randomly choose, and I'm going to put one of them into treatment 1, into the homework, and one of them into no homework, right? And I'll just flip a coin or whatever. So that's the idea of a match pairs. It's actually a subset of our block design, in that each block, if you think about this blocking here, each block just has 2 people in it. 2 people who are as similar as possible, and then we do our random assignment from each one. So that's the idea of a match pair design. Now, there are more subtle match pair designs, or more common ones. One of the match pair designs you'll see a lot is what we call there's a lot of twin studies. Our twin study that we do at UCSD is not necessarily a match pair design. We're using the fact that they're twins to try to figure out how much of these different things associated with aging are due to genetics and how much is due to environment. The way we do that is 100% of the identical twins, their genetics is the same, versus fraternal twins, it's 50%. So they sort of use that difference to then look and say, okay, well, how does the height compare across all of our identical twins? How does height compare against all of our fraternal twins? So twin studies are what led us to believe that height is 80% due to your genetics, and 20% is due to maybe childhood nutrition and other factors. So anyways, but many twin studies, twins are really good matched pairs, right? Another one that you'll see this very often in is before and after studies. Before and after studies are not necessarily the best in certain situations, but at SDSU we did a before and after study where we gave a pre-test and a post-test in our Stat 119. The idea was, before, you're basically the control group. You're the people who didn't get the treatment, right? This is before you've taken a stats class, how much stats do you know? And then the after is, okay, well, after the treatment, how much stats do you know? The answer was, it was disappointingly little that we taught them throughout the semester for this particular exam, because we really just did an excellent job of getting students to do well on that final, and not necessarily on this comprehensive conceptual test. But anyways, that was a very, 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 very long video about these 3 different experimental design methods that you might see on the exam.